Picture the most dramatic event in the universe, an explosion so powerful it outshines an entire galaxy. This isn't the plot of a science fiction novel, it's a supernova, a cosmic spectacle that dwarfs everything we know about scale and energy. A supernova is not just an explosion, it's the final act in the life of a massive star, a cataclysmic finale that lights up the cosmos. The life of a star is a constant struggle between the inward pull of gravity and the outward push of nuclear fusion. For billions of years, a delicate balance is maintained, until, at last, the star exhausts its nuclear fuel. Gravity gains the upper hand, and the star collapses under its own weight. This implosion triggers a shock wave that races through the star and rips it apart, resulting in a supernova. The scale of a supernova is truly mind-boggling. Imagine an explosion so intense that it outshines the combined light of every star in its galaxy. This is not hyperbole, it's a reality that unfolds countless times across the universe. The energy released in a supernova is staggering. To put it into perspective, it's like detonating a billion atomic bombs every second for several weeks. That's more energy than our sun will produce over its entire 10 billion year lifespan. But what's even more fascinating is the significance of these cosmic fireworks. Supernovas are the universe's recycling program. They scatter the elements forged in the heart of stars across the cosmos, seeding the universe with the raw materials for new stars, planets, and even life. As we delve deeper into the cosmic drama that is a supernova, we are reminded of the beautiful cycle of life and death, creation and destruction that plays out on a grand scale in the universe. Just as a caterpillar turns into a butterfly, a star too undergoes a spectacular transformation. The death of a star is not an end, but a beginning, a spark that ignites the birth of new celestial wonders. Let's journey into the heart of a star on the brink of becoming a supernova. Here in the star's core, a powerful process is unfolding. Nuclear fusion, the very engine that powers the star, is in overdrive. Hydrogen atoms are colliding at an unimaginable speed, creating helium and releasing a surge of energy. This energy exerts an outward pressure, counteracting the force of gravity that pulls everything inward. A delicate balance is maintained, giving the star its stable glow. But eventually the star exhausts its hydrogen supply. The core contracts, heating up further, and now helium atoms are under pressure to fuse into heavier elements: carbon, oxygen, neon, and beyond. Each fusion process releases even more energy, maintaining the star's radiance. Yet every star has its limits. Once the core begins to synthesize iron, the fusion process consumes energy rather than releasing it. The core's temperature soars, but without the energy to counteract gravity, it collapses under its own weight. In less than a second, the core shrinks from thousands of miles wide to just a few miles across. This sudden implosion triggers a shockwave, ripping through the star's outer layers. The star, once a beacon of light and warmth, now erupts in a cataclysmic explosion. In the blink of an eye, it releases more energy than our sun will produce in its entire lifetime. And so, in a brilliant burst of light and energy, a supernova is born. What happens after a star explodes into a supernova? With a brilliant flash of light and energy, the star's life comes to a cataclysmic end. But this is not the end of its story. In the aftermath of this celestial spectacle, the remnants of the star begin to take on new forms. The core that survives may become one of the densest objects in the universe, a neutron star. Picture, if you will, an object so dense that a spoonful of its material would weigh as much as a mountain. As it spins, it can emit beams of radiation, like a cosmic lighthouse. But sometimes, when the star is especially massive, even a neutron star cannot hold itself up. The core collapses further, becoming a point of infinite density, a black hole. But what of the rest of the star? The explosion of a supernova is so powerful that it propels the outer layers of the star out into space. This stellar debris, enriched with heavier elements like iron and nickel, then seeds the cosmos. These elements, forged in the heart of a dying star, are the building blocks of new stars, planets, and even life itself. From the ashes of one star's end, countless others may begin. It's a stellar cycle of birth, death, and rebirth. From destruction comes creation, a cycle as old as the universe itself. Why do these celestial fireworks matter to us? Well, allow me to enlighten you. Supernovas are more than just stunning cosmic phenomena. They're crucial contributors to the universe's cycle of life and death and play a vital part in our very existence. You see, during a supernova, a star explodes, spewing its elements across the cosmos. These elements like carbon, nitrogen, and oxygen are the building blocks of life as we know it. In essence, every atom in our bodies, the air we breathe, even the ground beneath our feet was once part of a star that went supernova. Moreover, these cataclysmic explosions distribute these elements widely, seeding the universe with the potential for new stars, new planets, and yes, new life. They're the cosmos' way of recycling and renewing itself. Supernovas then are not just dazzling displays of cosmic power but also the architects of life as we know it. So let's recap our cosmic journey. We started with the intense drama of the cosmos, where stars live and die, giving birth to awe-inspiring phenomena like supernovas. These celestial fireworks aren't just a spectacle, they're the cradle of a new star's birth, a process that starts with a massive star collapsing under its own gravity. In the aftermath of a supernova, we find a dazzling display of cosmic dust and gas, the building blocks for new stars, planets, and even life itself. This isn't just a random act of celestial destruction, it's a process of rebirth and renewal. The importance of supernovas can't be overstated. They are the cosmic alchemists, forging new elements within their fiery crucibles and scattering them across the universe. They shape the cosmic landscape, influencing the formation of galaxies and seeding the ingredients for life. Next time you look up at the night sky, remember the mighty supernovas, the cosmic alchemists that shape the universe and life as we know it.